What's up, everybody? Welcome back again. My name is Eric the Tutor. Today, we're still going over Aldol reactions. Now, I want to introduce something a little bit different. We're going to be working backwards from the Aldol. So we're actually given the product here, and we're trying to determine what our starting reactants are. Okay, so I'm going to go ahead and start by just drawing a very general structure here. So if we had something, let's say we had a reactant that looked like this. And I know there's an alpha hydrogen coming off of here, and let's say we reacted it with, some aldehyde. Let's go ahead and say with the OCH3 minus here. Well, then I know the OCH3 minus is gonna kick on a bond here, make this guy negative. So now we have something that looks like this. We got a negative carbon there. That's gonna be nucleophilic. I know this is gonna come out and attack a carbonyl there, right? So these are our general steps when we're discussing aldol. So notice our first step here was to use a OCH3, and we deprotonated this hydrogen here, and we formed a negative charge just like this, right? Notice what our starting reactants are in this product, right? So we have a carbonyl system here, and we also have a carbonyl system here. So I see a carbonyl right here. So I'm thinking that there had to have been a carbonyl pretty close to that, right? To form this di-conjugated system that we're going to have eventually. Okay, so I know I have some idea that we're going to be focused on this region in here. Okay, so we have a double bond in here, and there's some pi formation there, and I know if I carried out these steps and went a step further and showed this general structure and what's going on here, then this bond that formed is going to give us our carbonyl here. I'm going to draw this with an O minus and our two hydrogens there, and then I know we're going to protonate it. We're going to protonate it, and then we're going to have this structure with an OH, and here we have a, let's see, right here we have a alpha hydrogen. We have an OCH3 floating around that just occurred from that previous step, and that OCH3 can come, grab this H, form a double bond, and kick out our OH. And that's going to give us, that's a general structure of what we're going for. So if we are to work backwards, we know that a pi bond formation occurred between a carbon with the C double bond O. We hit a carbon, and then we had our pi bond formation would have formed in here, and then we hit another carbon. So up here, I see my carbon with a C double bond O, C double bond O. It's going to hit a carbon, and there it is. There's our pi bond formation, just like we had down here, right? So we had a carbonyl, hit a carbon, there's our double bond. Okay, carbonyl, hit a carbon, there's our double bond. So we know that the last carbon with that pi bond is going to have our OH group, right? It's going to have our C double bond O. So let's go ahead and give ourselves some space here. Okay. Let's go back to what we started with. So if I know that somewhere in here we're gonna have to break this bond. So let's go ahead and split these guys up for now. Let's go ahead and get these guys out of here. Let's go ahead and visualize this split down the middle here. So I have this big bulky group. And I have this. And I'm left with double bond O here, right? Now I know that our starting reactant can't look like this. We can't just split this down the middle. We eventually got to this. So I'm going to go ahead and erase this because I know it's not going to have that. I do know that it's going to be some carbonyl system, right? I don't know exactly what's here or here, but I can go ahead and make some deductions. Can we have two hydrogens here. Could we do this? Would they be able to react? The answer would be no. We would not be able to react these because there are no alpha hydrogens present, right? This is not an alpha hydrogen, nor is this one, because an alpha hydrogen needs to have an alpha carbon. There's an alpha carbon here, but no available hydrogen. Same as here, alpha carbon, no available alpha hydrogen. And these are not alpha carbons, nor are they alpha hydrogens. So we could not have that as a possibility. Let's go ahead and erase that possibility. So what if we had something that looked like an H here and a CH3 here? Well, that's a possibility. We could do that, right? We could also do an H on this one and a CH3 on this one. So how do we know which is going to be our best answer? How do we know if this should be a CH3 or if it should be an H? And how do we know if this is going to be a CH3 or if it's going to be an H? Well, we're going to have to trial and error. So let's go ahead and pretend that we have some OCH3 that's going to deprotonate this. We're going to skip a few steps here because we've done a few videos now showing how to go through this process. So let's go ahead and get our negative charge here. This is going to come out. It's going to grab a bond there. So now we have here's our new carbon bond with an O minus, just like this. Okay, let's give ourselves some space. We have some HOCH3 floating around to reprotonate this guy, so this is going to become OH, and then that's going to give us some OCH3 minus in here, which is going to grab this, kick that out, and then kick our OH out. Now let's go ahead and draw what that looks like. Now, our double bond goes right in here. But, does this product look like the product that we started with? Is this the product that we were trying to find its reactants for? Let's go ahead and look, right? So we had a benzene ring here with the OHs. Coming off of it, we had a C double bond C, then we hit the carbonyl, okay? Notice how this benzene that doesn't have anything on it directly has a carbonyl coming off of it. So let's go ahead and see if we have that. So we have here, directly coming off of this benzene, we have the carbonyl, and then we have the pi bond, and then we have our benzene ring with nothing on it. So we actually chose the wrong reactants to give us the product that we're trying to find. So that means earlier we're going to have to flip our initial hypothesis that this one is going to have the CH3 with the alpha hydrogen that will become deprotonated with this hydrogen. So this aldehyde should be on this group with the OH and with the benzene and the OHs, and this group on our right shouldn't have the aldehyde. It should actually have our C double bond O CH3 group with our alpha hydrogen. So let's go ahead and draw that down here. Let's go ahead and draw that. So we have starting products, OH, OH. We know this is going to have our aldehyde. And then we know our other benzene ring with nothing on it is going to be our CH3 here. So these are going to be our reactants. Go ahead and give it a try and see if you can find the product that our question started with. Okay, so if this was negatively charged, then we know it's going to form a bond in here. So if I just do some quick steps here, that's going to push this bond up to an O minus. Let's going to push that to an O minus. This whole group on our right here is going to become attached. So we're going to have something now that looks like a benzene ring. This will be protonated after it grabs a hydrogen. Let's go ahead and put a hydrogen on here. We have our OH group now. We have an alpha hydrogen. We can have a OCH3 group come and grab the hydrogen, form our double bond, kick out our OH group. So now we know that's going to give us the final product that we started with. The product that we were trying to work backwards from. So now we have pi bond in here. And we can see that our benzene ring with nothing on it has the carbonyl directly on it, just like our initial problem asked for. And our benzene ring with their alcohols have our pi bond coming off. So now we know this is our final product. And we figured out our starting products were the aldehyde with our OHs and our benzene ring with the CH3. That's what we were looking for. Alright guys. Good luck studying.